Okay, welcome back. This is video over 7.1, and we're going to be doing radical expressions and functions. Okay, so let's talk about what a radical expression is. We have this notation here where we take the nth root of a, okay, and that's how we read that, all right? And so the root or the index is the number here, okay? And then the radicand is what is underneath the radical sign. So let's kind of talk about like what this all means. So when radicals and exponents kind of go hand in hand. Okay, so radicals and exponents are related. Okay, they are related to each other. All right, now what I want to think about is this. All right, let's just kind of think of a few things here, like 1 squared, okay, would be 1, all right? If I take the square root of 1, I'm going to get 1, all right? Not the best example, but let's look at something else. Okay, let's look at 2 squared. If I take 2 squared, that's 2 times 2, which gives me 4. If I take the square root of 4, that's going to give me 2, all right? If I take, say, 3 squared, it's going to give me 9. So if I take the square root of 9, I get 3. All right, that's what a radical is, all right? Now, we can kind of think of something else. Like, let's say we take 2 cubed, all right? That's going to give me 8. So if I take the cube root of 8, it's going to give me 2. Get back to where you started at, okay? If I take 3 cubed, that's going to give me 27. 3 times 3 times 3 is 27. If I take the cube root of 27, that's going to give me 3. All right. Okay, the next one I want to talk about, and let's just make this as easy as we can. Let's just think of the number like, say, 2 to the 4th power. Okay, would be 2 times 2 times 2 times 2 is going to give me a value of 16. So then if I take the 4th root of 16, it's going to bring me back to my base, which is 2, okay? So that's the idea behind radicals, okay? It kind of just undoes or is the opposite of taking something to a power, okay? It brings you back to where you need to be. All right, let's think of something like this, though. Let's think of, like, say, x squared, okay? What you're doing here is you're doing x times x, okay? And that's going to give you x squared. But what happens if you take the square root of x squared? What do you get? Brings you back to x, okay? So what we can say about radicals and exponents is that essentially they are what's called inverses of each other, okay? So if you think about this, like, and let's just think about this. Let's just think about the word opposites. Okay, what's the opposite of addition? Subtraction. What's the opposite of multiplication? That would be division. What's the opposite of taking something squared? The opposite would be to take the square root of something squared, okay? And that's kind of the idea, all right? And we're kind of leading to that concept of how do I undo something squared? How do I undo something that's cubed? How do I undo something that's raised to the 4th power? We take the square root, we take the cube root, take the 4th root, okay, and so on. All right, so let's go down. Let's kind of look at some of these examples here. And we also have this thing where it says basic properties of radical numbers. And let's just kind of take these as we go. All right, so let's take a look at the first one. What I want to do is take the negative square root of 121. Well, what I know, it's going to be 11, okay? But what I know is this. 11 squared gives me 121. So if I take the square root of 121, it's going to give me 11, and we're going to make it negative on the outside. All right? So pretty simple, pretty easy, if we've seen this before, okay? On this one, when we have a fraction, what I can do is I can separate this out into the square root of 36 divided by the square root of 49. All right, so the square root of 36, two numbers that multiply to 36 that are the same is going to be 6. And then the square root of 49, two numbers that multiply to 49 that are the same is 7. So that's our answer is 6/7. Okay? All right. Now, that's just with numbers. Okay? Not too terrible. Not too bad. All right, but what I want to look at is introducing this concept of a variable. Now, what I can do, if I have the square root of 16t squared, I can rewrite this as the product of two square roots. Okay, I can say the square root of 16 times the square root of t squared. Okay, and that's what I typically want to do when I'm separating these. Okay, and the square root of 16 is just going to give me 4. All right, but if I take the square root of t squared, this is going to give me t. All right, and I know that from the example that we had up here, because remember, the opposite of squaring something is taking the square root, and brings me back to what we had underneath. Okay, and that's my answer. All right, so I'm going to circle that. All right, let's take a look at part B over here. Now this one, looks terrible. Now here's the thing. What I did over here, notice how when I separated this out, when I had the square root of 16t squared, okay, notice how I separated this out because I was multiplying things. Okay, on B, what you notice that's happening under the square root is that I'm adding things. All right, so what I want to think about is, well, can I factor this? All right, what two numbers multiply to 64 but add to 16? And that's going to be 8 and 8. So look what I got. So I got the square root of y plus 8 times y plus 8. All right, the reason why I did that is because I wanted to get something involved with multiplication, because the only thing that I'm multiplying here is 16 and then y squared, but everything's separated by plus and minus signs. But look what I have. I have something times itself. So check this out. This is where it gets really cool. I get the square root of y plus 8 quantity squared. Now let's think about it. What happens when I take something squared and take the square root of it? It eliminates the square. So what we're left with is just y plus 8. And that's it. Okay? All right, let's take a look at part C. Part C, that wants me to take the square root of negative 81. Now, before I do anything, I'm going to say that this can't be done. Okay, there does not exist. All right, D and E. Okay, does not exist. Okay, now the reason why is because, if I think of like 81, okay, I think of like 9 times 9 gives me positive 81. What about this? What if I took negative 9 times negative 9 is equal to positive 81? So the reality is that there are no two numbers multiplied by themselves to give me a negative number. Okay, so we can't take the square root of a negative number. All right? Now that idea will change because we're dealing with other indices, like taking the cube root of something. That we can take the square root of negative numbers. We'll talk about that here in a little bit. So I can't take the square root of a negative number. Okay? All right, let's take a look at part D. Now this one you can. All right, now let's think about this. 27 is a perfect cube. All right, 27 is given to me by doing 3 and cubing it. Okay, so if I think of this as 3 times 3 times 3, I'm going to get 27, and that's how we get that number. But let's think about this. What if I did negative 3 times negative 3 times negative 3? Okay, if I take negative 3 times negative 3, that's going to give me positive 9. Multiply that by a negative, it's going to give me a negative number. All right, so kind of have some interesting things here. All right, so if I can take the cube root, if I take negative 3 and cube it, I'm going to get negative 27 out of that. All right, so if I were to take the cube root of negative 27, that would just simply give me negative 3. Okay, so let's talk about this. We have a conclusion that we can draw. Okay, so the conclusion, okay, and I'm just going to write this out here, the nth root of some number a, okay, what we had above, all right. If n is positive, or if n is even, okay, a must be positive. Okay? If n is odd, then a can be positive or negative. Okay, it doesn't matter. All right, and we saw that here. You know, on part C, your index is 2. All right? You know, if there is no number, then your index is 2. But here our index was 3. So what we can do is we can just do, you know, we have to think of this idea. If n is even, if this little number is even, this number has to be positive. Okay, it can't be negative. If your index is odd, it can be positive or negative, doesn't matter. All right? Okay, let's take a look at this one. Now this one's pretty easy, okay? We want to simplify this. Use absolute value notation when necessary. So what I know about this is that if I take the 6th root, x to the 6th, it's just going to give me x. If those numbers are the same, it's just going to give me what I need, all right? And that's the idea, all right? For part B, 5th root of a to the 5th, it's just going to give me a. All right, now they talk about using absolute value notation when necessary. So let's go back up here, okay? And it says here, we get a if n is an odd integer greater than 1. We get the absolute value of a if n is an even integer greater than 1. So now what we actually get this. Absolute value of x.
But a stays
A stays a. Now here's why, okay? If I take the square root of 16, that's going to give me 4, right?
Yeah.
Could also give me negative 4. Okay?
The absolute value.
So it's the absolute value because you can get those two different values, all right? Because your answers could be negative, all right? And that's why. And the reason why this works is because you got 4 times 4 gives you 16. If I take negative 4 times negative 4, we get 16 as well. So this, positive and negative 4, is our answer. And that's going to come into play later when we start solving more quadratic equations, okay? All right, let's take a look at the next page. All right, so on this page, let's take a look at the first couple questions here. It says, example, simplify, assuming that all variables represent positive numbers. So what I want to do is first take a look at this example A, where I want to simplify the square root of the quantity negative 5b squared. Now remember what we have, okay? Let's just think about something here. All right, remember when we take the square root of x squared, how that just is going to give us the value of x, okay? And we did this on the previous page, but what we can do is, because we're taking this quantity and squaring it and then taking the square root, what that does is that's just going to undo the square. So we're just going to get negative 5b out of this, and that's my answer, okay? So not too terrible, but it's just about recognizing what you're doing and all that. Okay, now the other thing is this, okay? Something like this, where you have the square root of a to the 14th power. I want to look at the square root of x squared. Notice what happens. Notice how the, if I take this 2 here, it becomes 1. Well, the question is like using multiplication, 2 divided by what gives me 1, okay? And that answer is 2, okay? So if I were to do this, you know, a to the 14th, you know, one way that we could do this is we could split this up and rewrite it like this, as a squared times a squared times a squared times a squared. 1, 2, 3, 4, 5, 6, 7, okay? And so, you know, when you see this, you know, all you've got here is you've got the square root of a squared. I can split this up into separate ones, times the square root of a squared, times the square root of a squared, times the square root of a squared, square root a squared. All right, and that's what I've got. And so we're just going to multiply all these together, okay? Now, when I take the square root of a squared on each of these, that's going to end up just giving me a. Okay, so I've got a times a times a times a, 5, 6, 7. Okay, and that's going to end up giving me just a to the 7th. Okay, so this is the long way of doing it. Okay, but splitting up a to the 14th, 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2 is going to give me 14. All right, and that's I can rewrite a to the 14th as the product of all these a squareds, and then I can separate it out into these individual square roots of a squares, and that's going to get rid of all the square roots, and then we have 7 of those left over. Now, what we could just do, okay, so that's the long way, but the shortcut, one way to think about it is if you take the square root of a to the 14th, that's really just doing a to the 14th over 2 power, which gives you a to the 7th. All right, and so we'll kind of explore that more so as we go on, but I would consider, the option of splitting this up into the product of numbers. All right. On the next part, it says determine the domain of this function f. So you have this radical function, f of x is equal to the square root of x plus 8, and what I want to realize here is that anything that we take the square root of, this value must be positive, must be greater than or equal to 0, okay? So, and the reality is we can't take the square root of a negative number, so we can't take the square root of a negative number. So, what I want to do is simply just take what I have underneath the radical symbol, which is x plus 8, and set that greater than or equal to 0. Okay, and then if I subtract 8 from both sides, all right, then I'm going to get that x is greater than or equal to negative 8. Okay, now what I want you to see here, I'm going to graph this on Desmos, and then you can kind of see what I mean by that. All right, and so here's my Desmos graph, and so I went ahead and just graphed that function f of x equals the square root of x plus 8, and what you notice here is that the domain, this graph starts at negative 8. And all of the points on this graph, okay, all these xy points along this graph are would have to be larger than negative 8, okay, or equal to, okay, because you do have that one point down there that you could have that is x is equal to negative 8. All right, now let's go ahead and take a look at this last few examples before we get out of here. And what I want to think about is something like this, okay. We want to estimate the following radicals without using a calculator. Okay, if I went in and used a calculator, I could take 22 and find the square root of it, and it's going to give me about, if I plug this into the calculator, it's going to give me approximately 4.7. Okay, so approximately 4.7. But what I want to do is think of the number 22. Okay, 22 is not a perfect square. Okay, the numbers that are a perfect square around that would be 16 and 25. All right, now if I took the square root of 16, that's going to give me 4. If I take the square root of 25, that's going to give me 5. So if I take the square root of 22, it's going to be in between 4 and 5. Okay, it's actually 4.7. So a good estimate would be like 4.6, or 4.7. Okay, would be like reasonable estimates, something close to 4.7. You're not going to be, everyone would probably have a different estimate when they do this, but that's the idea. All right, so let's look at the next one, the square root of 50. All right, now what I know is this. I know that that's really close to the square root of 49, okay, and that would give me 7. And this would give me the square root, if I looked at, like, say, the square root of 64, that would give me 8. Now, 50 is much closer to 49. So I would venture to say that this would be about 7.1 or so. Okay, and I use the approximation symbol. And let's just check that real quick. 50, take the square root, and that gives us, on the calculator, so the calculator gave us about 7.07. Okay, if we were to round that up, we would round that up to 7.1. So we are, pretty able to do this. Okay, the cube root of 28, this is really close to the cube root of 27. Okay, the other really close cube root would be the cube root of, say, 64. So the cube root of 27 is going to give me 3. Cube root of 64 is going to give me 4. All right, so it's going to be much closer to 3. So if I take the cube root of 28, that's going to be approximately say, I don't know, I would do 3.01 or something like that. But if I take 27, raise it to the, okay, so if I do 28, in doing this in the calculator, this is the same thing as doing 28 to the 1/3 power, okay? And we'll talk more about that later, but actually on the calculator, pretty cool, they gave us that this is approximately 3.03. So we're pretty close, all right? So you kind of just have to estimate and guess and see what those are. So kind of a unique thing to do to evaluate some radicals, because sometimes a lot of those radicals you can't really do by hand. You have to estimate them, and that's kind of the method how to do that. So get started on your homework, and we'll see you guys in a bit. Thanks a lot. Bye.